Okay, today we're going to show you about templates. We're going to talk a little bit about what they are, why they're important, and then how to use them. Before we do this, I want to show you an example. Can you spot the error in this code? We've got a minimum function, which takes two parameters, and it returns back the minimum value. But if you look, here it's calling it and it's displaying the minimum value, but it's sending double values or floating point values. If we were to use this function, it would crash because we're sending 3.2 to an int value. So here's kind of an example of the error you would get when you try to compile your program. Now, we could do this with redundancy. We can have a minimum function that works for ints, and then a minimum function that works for floats, or a minimum function that works for doubles, and then it would work no matter what. Or we could use templates. Okay, template, there's a class template or a type name template, and there is no difference other than the keyword class or the keyword type name. So really, I don't know why they have both. I'm probably going to use class template from here on out, but know that you can use and you will see the word type name. So in this situation, I put a template first, and I'm saying class T. That means T is going to be a variable for the type of data I'm using. So in this case, instead of returning an int now, I'm returning T. And then I have my minimum function and my data types T. And then it's going to return, this is just a shortcut notation for an if statement. If this is true, it returns this, otherwise it returns this. So in this case, no matter what data type I send it, it's always going to return back. It's going to work, whether it's strings or ints or doubles or objects or whatever it is, it's going to work. Okay, there are function templates and there are class templates, and all that means is you can have a templated function in your class, or you can template the entire class. So now we've seen some of these. We've used vectors before, and that is a templated class. That's something that we can specify and it will work for our like we've used vectors for ints, and we've used vectors for doubles, you've used vectors for now employees. It works for any data type. And that's because a vector is already a templated collection. There's also an array collection, and what you do is you include array, and it still has the pushback, but it has a begin and an end. So let's kind of give you an example. Here I have int array int. I'm going to make it a default size is 5, and I'm going to call it my list. And so in this particular situation, the list is size 5. I can fill the array, or I can use an initial list on my array. It's just another way of using an array with this templated list. It has a couple of other capabilities in there. Size will determine the size of your list, and you still have your operator to be able to display all the information in your list. So that is an array template. You can use a for each loop, which is kind of cool. I can say for auto L colon my array, and all that will do is auto means it's going to automatically specify EL as whatever type my array happens to be. So in this situation, EL becomes every value in the array. So it's doing a cout statement for every value in the array and then putting a space after each. Okay, so that's the array STD template. We've done the vector, just a quick little review. You include vector, there's pushback, begin, end, size. You still have an overloaded operator to be able to access each element. So you can instantiate it with vector int mylist. This would instantiate an int list. This would instantiate a double list, but it works because the class is templated. In this, you can specify the size, the initial size, and as you add items, it will change the size of the vector. So here is, it's adding I to the vector, so it's adding all the values 0, 1, 2, 3, 4, 5 using this pushback. Here's one way to display. You have a a for loop that iterates through, and it's using the overloaded operator for the brackets to display each item in the array. Or you can use your auto and start at the beginning of the list. So long as you're not at the end of the list, it's going to go through one at a time and display a pointer to each of the values. So it kind of depends on, do you need a pointer to the object or do you need to access the item itself? Advantages of a vector is you have direct access to the data. Your memory management is done for you. Disadvantages, if you add to the end, it's pretty efficient, but if you add like to the beginning or something like that, you can't, it's not quite as easy to do. Now you can do a stack. A stack is built in into C++, and it is a templated object. To use a stack, you include stack, and your objects, your functions are, you have push, popped, empty, size, top. We've created a stack before, and we're going to use that same code in ours to create this one, but this is a built-in one. So here's how it would work. I've got my stack. I could say my list.push, and it would add these values on. If I do a peek, it's going to show me the top value in my stack, so that would be 4. If I pop, that would show me the top value. It would remove the top value from my stack, so 4 would be gone, and I could peek and see a 42. There's also a queue built into the std library. You just include queue, and it has push, pop, empty, sees if it's empty or not. Size tells you how many elements are in there. Front, back returns both the front or the back values. So here's an example of an int of queues. Same example, and in this situation it's adding 10 to the front, adding 42s in next, and then 4. So if I view the front of the stack, that's going to be my 10. Back is going to have my 4. If I pop, that's going to remove the front of my stack, so I would be left with 42 and 4. Okay, I'm going to pause the video there and catch us in the next video, and we will talk about creating your own class templates.